Hello students. So in the earlier session what we have discussed is something regarding dispersion of light. So dispersion of light, as I already explained, so when ray of light enters, for example a prism, means yes, it splits into constituent color. So according to the definition of dispersion, we know that dispersion is defined as when a composite light splits into constituent colors, and that is known as dispersion of light. How you can do that one? Just by using one of the basic experiment by using a prism. Suppose a ray of light from sun falls on the prism, means you can see the constituent colors. So right now, along with that one, so this is how we can artificially do that one. So is there anything something like that happening in the nature? Yes, of course it's happening in nature. That is what we call rainbow. So what is rainbow now? Yes, we know during rainy season, suppose it has rained, and soon after that one, suppose hot sun is there or sunshine is there, means we can see the colored sequences or colored pattern in the sky. So we know the name, it is rainbow, we usually see that one. So there also the concept of dispersion takes place. So today what we do is we are going to discuss about formation of rainbow and how many types of rainbows are there. We'll discuss about that. So before that one, we'll know about something. So spectrum means, you know, that is orderly arrangement of a different colored light, or you can say different colored or wavelength of light. So it's actually a pattern. Suppose you are able to see that very distinctly. That means very distinctly in the sense you can see clearly VIBGEO. That means violet, indigo, blue, something like that. Means it is actually called pure spectrum. So one more type is there, that is impure spectrum. So what is impure spectrum means? You cannot see that distinctly, in the sense maybe overlapping of violet with indigo or yellow with red, something like that, which is actually seen in rainbow. So rainbow is not a pure spectrum. Rainbow is actually a impure spectrum. So what about pure spectrum then? Yes, of course, that is prism. Suppose prism is actually used for dispersion, that means we can say it's actually a pure spectrum. So today what we do is, so we'll just discuss about how exactly we can frame the ray diagrams, how to understand the formation of rainbow. So let us discuss about that one. So right now what we do is we will discuss about the formation of rainbow. So already we know how exactly rainbow is formed because of the dispersion of light, and what type of spectrum it is. It is actually a impure spectrum. So of course we usually see during the rainy season, yes, there will be a rainbow formation. It's quite natural. But there are two types of rainbows are there. So first one, that is primary rainbow, and one more is secondary rainbow. So now, how exactly it will happen? That means what is the science behind it? So for both cases, we have got criteria. What is that? First, the condition for formation of rainbow, I will write down here. So that is first one, that is refraction. Refraction will happen, and the second condition, that is total internal reflection. So now let us see how exactly it will form, how to understand the primary rainbow formation. So rainbow means it's actually impure spectrum. It is all because of the dispersion of light. And what are the conditions for dispersion of light in the water molecules in the atmosphere? The conditions are refraction will be happening there, along with that total internal reflection will take place. Because of these two combinations, rainbow is formed. So two types of rainbow, primary rainbow, secondary rainbow. Right now we'll discuss about primary rainbow. The diagram is already drawn here, you can see. So well, already in the prism concept regarding the dispersion, I told you violet will bend more, whereas red light will bend less. So that is how dispersion concept is discussed. Right now you can see here water drops are there, and this is actually the sun, and here is the observer. So imagine that it has rained and water molecules are there in the atmosphere. So parallel ray of light will come from the sun. So sun rays, so like this. So once the ray of light enters or strikes the water drop in the atmosphere, of course, what happens? Refraction takes place. As it is a composite light, here also what happens inside the water molecule is dispersion takes place. So once dispersion takes place means how exactly dispersion takes place here? First, refraction of light takes place. Refraction means what? Which is bending more? Violet is bending more. Which is bending less? Red is bending less. So soon after that, here what's going to happen? You can see here reflection is taking place. That means ray of light is traveling already inside the medium, water medium, trying to go out. No, it's reflecting back. That means total internal reflection. So the conditions are satisfied here. You can see what are the conditions that should be satisfied in order to form a rainbow. There should be refraction as well as total internal reflection. So how many processes are taking place here? Refraction, total internal reflection, again refraction. So what are the process in forming primary rainbow? Refraction, total internal reflection, again refraction. That is how it is formed, and that is called primary rainbow. Let us explain about this one now. You can see here how properly diagram is done here. Observer, I it is, and this is sun. So parallel ray of sun rays. I have taken 2 water droplet. Minimum it is required to show the formation of primary rainbow. You can see once refraction takes place, light will split into constituent colors. So the least bending was red, as well as much bending is all about violet. Soon after total internal reflection, again they will frame like this. And look at here, ray of light, whipjaw. That means violet will go in this particular direction, red will go in one particular direction. Similarly, one more parallel ray of light was coming in the same direction, and it was entering this one more water droplet. So once it enters that one, again here also, once it enters, refraction, then total internal reflection, again refraction. So in this way it will take place. So red line will refer the red light, violet means as you can see here. And now I have shown you which and all the ray of light are going to that means form, with what angle they are going to align with the direction of ray of light from the sun. See, these are the 2 lines which are actually parallel to the rays which are coming from the sun. That means with what angle they are going to align. Soon after the dispersion as well, that means total internal reflection and again refraction, they are going to, so whipjaw, that means violet ray, after the formation of rainbow, the ray of light will be having around 40 degree, it will frame along with the parallel ray of light with the sunlight. Okay. What about red? Red will be having the angle of 42 degree when it is already formed the rainbow. And now how exactly it looks to the particularly the observer. So how he feels. So which and all colors he will see. Always remember, for primary rainbow, once it is formed, minimum 2 drop, okay, you can see here, red will be at the top, violet will be at the bottom. So this is how the observer will see the rainbow, and the pattern of the rainbow will be top will be red, bottom will be violet. And these constituent colors, with what angle they are going to form with the ray of light which is received from the sun. You can see violet light will form 40 degree. What about red? It is 42 degree with the direction of ray of light from the sun. So I repeat once again, primary rainbow. So before that, formation of rainbow we are discussing. It's an impure spectrum or spectra, we can say. There are 2 types of rainbow. First one is primary rainbow, second one is secondary rainbow. So how to understand primary rainbow? Yes. So parallel ray of light is coming and 2 drops that we have considered. Once the ray of light enters the water molecule, dispersion takes place. That means refraction it is. So once the refraction takes place, again total internal reflection takes place. Again refraction takes place. But bending of the red light, violet light takes their own angle of bending. So you can see what is the value of them. So for observer who is seeing a primary rainbow, red will be at the top, bottom will be the violet pattern. So that is how the primary rainbow looks for a observer who's actually looking at the rainbow. One more condition is, what is the position of the observer in order to see a rainbow? Always he has to face the atmosphere where the water droplets are there. From his same direction, ray of light has to come and hit, and again once they get total internal reflection, they have to be received from the eyes of the observer. That means sun and observer will be in the same direction. Water molecule, that means moisture in the atmosphere, in the opposite direction. So this is actually the condition in which this will be formed. If the observer is standing somewhere here and all, means it is not at all possible. So this is all about primary rainbow. So one of the type of rainbow formation, that is primary rainbow, we have discussed, and hope it is very clear for you people regarding the ray diagrams. So you just follow the ray diagrams because it is very clearly it is drawn along with the different colored rays. So violet ray separate, red ray separate, and along with the angle with which it has subtended with the ray of light which is received from the sun. So now what we do is we are going for the second type of formation of rainbow. So, and that one is, what is that? That is secondary rainbow formation. So right now secondary rainbow formation, you can see the diagram is slightly different here. So what is that? Yes, of course, sun is there. So from sun, what is happening? Here it is actually ray of light, parallel ray of light is coming, and minimum 2 water droplet we are going to consider. So one of that ray of light. So one here, one more here I have taken. These are just references in order to show with what angle they are subtending with the direction of sun. So now one ray here, one more ray of light here, and they are going to enter the water drop like this. So once they enter, of course, what happens when ray of light enters from rarer to denser? It bends. So when it bends, what happens? Because of the composite light it is. It's a composite light, it splits into constituent colors. Which one bends more? The violet will bend more. Which one bends less? That is red. But here you can see that earlier it was like just a total internal reflection, again it gets back. But here double total internal reflection is happening. So double total internal reflection means, yes, for what are the processes which is undergoing in case of secondary rainbow? First, ray of light strikes the rainbow, that means water droplet, refraction, double total internal reflection, again refraction. So what are the process which is undergoing in secondary rainbow? Yes, first one, refraction, double total internal reflection, and again refraction. So what and all the things, properties we can understand from this secondary rainbow is, of course, water drop should be facing the sun, observer also should be in the same direction of sun, okay, that means like this. And now when parallel ray of light strikes the water droplet, what happens? Refraction takes place, double total internal reflection, 2 times total internal reflection takes place, and then light again refraction takes place. And you can see here when the observer sees, in the earlier case, that is primary rainbow formation, and you knew that what and all the angle with which the violet as well as red light is going to form in the direction of ray of light which is received from the sun. Here you can see the angle with which the violet ray which is going to be bending, it is about 53 degree, whereas the red light, a red ray of light which will be forming, that means which will be subtending in the angle of 50 degree with the direction of ray of light which is received from the sun. Now what about observer? Because in the previous one we have understood that, yes, that means red will be at the top, violet will be at the bottom. That is what the spectrum or the colored pattern the observer can see. So when he looks at a primary rainbow, the topmost color will be red, bottom color will be violet. That is how, because it is mixed one, it overlaps. It is not a pure spectrum, it's an impure spectrum we have already discussed. And now here in this case, what is that? Secondary rainbow. What is that? Okay, you can see here, violet will be at the top, red will be at the bottom, just reverse. Now, there are 2 types of rainbows. Which one will be more intense? So, answer is primary rainbow will be having more intensity compared to secondary rainbow. So, earlier, for what are the conditions for the formation of primary rainbow? First one, the rainbow formation of, that means primary rainbow, first conditions, that is ray of light has to undergo refraction, then total internal reflection, then again refraction. And angles also we have discussed, which is more intense, primary rainbow. Next, in case of secondary rainbow, how to form secondary rainbow? Yes, there will be refraction, to double total internal reflection, again refraction. Which will be the, that means what is the color pattern with the top? That is violet, at the bottom it is red. You can see here also red violet is there, but which is received from our eyes will the pattern will be in this particular way. So up violet, bottom red. In primary, up red, bottom will be violet. So that is how primary and secondary rainbows are formed, which is the ray diagrams also we have discussed here. Hope it is very clear for you people. So carefully look at the ray diagrams, the previous one as well as now what I have done. So along with that, so closely have a look on the diagram. So you also have to practice this. So here you can see what are the conditions and all I already explained. So which is more intense? Primary rainbow is more intense. Secondary rainbow is less intense. And refraction, total reflection, that is what going to take place inside a water drop or molecule. So from there, not molecule, sorry, so water drop. So from there, the formation of rainbow is taking place. So any queries or any doubts suppose you're having means, you can inbox me to my personal phone number. So hope it is very clear for you people. Today we have discussed about different topics which are general and as well as naturally occurring phenomena. Thank you.